All right, today I want us to check the concept of impulse. Okay, so impulse is a physics term that refers to the change in momentum. So when you don't want to say change in momentum, you can say what? Impulse. Okay, so this is a vector quantity, and the definition is here on your screen. Or we can choose to define impulse as the product of the force acting on an object and the time interval during which the force acts on that object. Okay, so now how do we find the formula for the impulse? Okay, so from our previous lesson we learned that this is Newton's second law of motion in terms of momentum. Okay, so when we multiply both sides by changing time, okay, then our formula becomes like this. Okay, so it says F net multiplied by changing t is equals to changing p. So it means our momentum is equals to what? The force applied to an object over a certain period of time, which this expression here, we call it the impulse. So the impulse, mathematically, it says that F net multiplied by changing t. Okay, so this is the relationship to momentum and Newton's second law. Okay, so because according to Newton's second law of motion, the change in momentum of an object is directly proportional to the impulse applied to it. Okay, so mathematically, or if you want to write the English, we know that the impulse is equals to change in momentum. Okay, so this is mathematically, then this is the English part. All right, so this means that when a force is applied on an object for a certain amount of time, it causes a change in the object's momentum. All right, so remember what's important here is that we're having change in p, which is change in momentum. Okay, and we know that this is measured in kg meter per second. Okay, and then now when we're having F net multiplied by change in t, okay, we know that the force, any force, is measured in what? In newtons. Okay, and then time is measured in what? In seconds. So it means that the SI unit for impulse can be Newton second or kg meter per second. So it means that 1 Newton second is equivalent to 1 kg meter per second. So any of these SI unit is good for the impulse. All right. So, and this impulse is a crucial concept in understanding collisions. Okay. So, understanding impulse is so important for analyzing the impact of a tackle or the impact of the force required to stop a moving object. Okay. So, I think we can look at the example below so that we get to understand the concept of impulse. But in the meantime, we just know that the impulse is just another way to say changing momentum. So let's look at this example here. So it says that a cricket ball of mass 175 gram is thrown horizontally towards a player at 12 meters per second. Okay, and it is hit back in the opposite direction with a velocity of what? Of 30 meters per second. Okay, and then the ball is in contact with the bat for a period of 0.05 seconds. So the first question they say to us, calculate the impulse of the ball. Okay, so before we analyze the question, we know that when you talk of impulse mathematically, we have to remember that the formula for impulse, it's changing, or it's F net multiplied by changing T, which is equals to changing P. Okay, this is the formula for impulse. Okay, so now back to our statement. Okay, now we have to do the analysis. Okay, we're given a ball, a cricket ball, which has a mass of 175 gram. Okay, and then it's thrown horizontal towards a player. Okay, so it's thrown horizontally, just like this, towards a player here. Okay, and it's traveling at a velocity of what? Of 12 meter per second. Okay, so now the player hits the ball in a different direction, and then the ball now has a different velocity. Okay, so it means now here is our cricket bat. Okay, then the player hits the ball in a different direction, in the opposite direction, with a velocity of 30 meters per second. Okay, then they told us that the ball is in contact with the bat for this period of time. Okay, so from this scenario we can see that we had the initial stage of the ball. Okay, and then it was thrown, it had a velocity initially, and then after there it changed the velocity and the direction. So it means here we can get what we call the change in momentum of this cricket ball. Okay, and remember, if we have the change in momentum of the ball, it means we found our impulse. Okay, so now remember, this is a vector quantity, so it means we have to take direction. So let's consider this motion, any motion going to this direction, the initial part of the ball, to be positive. So it means any motion going towards that 30 meter per second direction will be considered negative. So it means the velocity here is positive, and then this is negative. Okay, so now we are good. Okay, so now we know that this is mass into V final minus V initial. Okay, initially this was our velocity, and then this is our final velocity. Okay, so remember that the SI unit for momentum, it's kg meter per second. Okay, but we are given our mass in grams. So to convert that to kg, it means we just have to divide this by 1000, and then we get that our mass in grams, in kg, I'm sorry, it's 0.175 kg. And then our V initial, it's positive 12 meter per second, and then our V final, it's negative 30 meter per second. Okay, then now we can calculate the change in momentum of this ball. Okay, which is the same as calculating the what? The impulse. So our mass, now we're going to use the mass in kg. So it's 0.175 into our V final, it's negative 30, and then we have minus into positive 12. Okay, then when we get our calculator, we get that our answer becomes negative 7.35. Okay, so it means that this negative is showing us the direction in which the momentum is changing. Okay, so it means that we can say our final answer is 7.35, okay, kg meter per second. Okay, then the direction of the direction of this change in momentum, okay, because the ball was hit by the bat, okay, then it's moving away from the bat. So it means we can say the ball is moving away from the bed. This is what the negative is showing us, the direction at which our momentum is changing. So it means we have calculated our impulse. Then we can move to the second question. So the second question says, calculate the force exerted on the ball by the bed. Okay, so now I want us to check something here. Okay, remember we found our change in momentum. Okay, and these were the SI unit. Okay, and remember we said 1 Newton second is equals to 1 kg meter per second. So it means even if someone write the answer this way, Newton second, I'm sorry, this is a small s for second, and then this is still correct. Okay, so now the second question wants us to calculate the force exerted on the ball by the bed. Okay, so we use the same formula. F net change in time is equals to our change in P. Okay, so remember that we found our impulse, okay, as changing momentum to be 7.35. Okay, so now we want the force, so it means we keep our F net because we want our force. Okay, and then now there is this important information. Okay, to find the force exerted on the ball by the bed, it means that is that moment whereby the two were in contact, and they were in contact for 0.05 second. So that is how we're going to find the force exerted by the ball or on the ball by the bed. Okay, so it means now the time it took or the time of contact between the two was 0.05. Okay, then it means we are going to divide both sides by 0.05, 0.05. Okay, and then now we get that our force exerted will be, then when we get our calculator, we get that this is 147 newtons. Okay, and remember this is a force, it must have magnitude and direction. Okay, so the direction here was away from the bed, so even here the direction is still the same, it's still away from the bed. Okay, because the answer that we got was negative. Okay, so it means this, when we simplify it, we would have got this answer, and then when we put the units and everything and the direction, this was our final answer. I hope it makes sense. Okay, so let's check on the last question here. Okay, the last question says calculate the force exerted on the bed by the ball. Okay, and then you should motivate your answer by referring to what? To a law of motion. Okay, so remember the force exerted on the ball by the bed is 147. Okay, so now if I apply a force, let's suppose this is a wall and then I'm standing here. Okay, if I apply a force on the wall will exert what? The same force but in opposite direction. Okay, so now we know the force exerted by the bed, okay, on the ball. So now they want us to calculate the force exerted on the bed by the ball. Okay, so it's just a two-way thing but in opposite direction. So it means now we know the force exerted on the bed by the ball, which is 147 newtons. Okay, but in this case it's towards the bed, because this should be in opposite direction to our answer. Okay, so when we motivate our answer, okay, we are going to say, according to Newton's third law of motion, okay, the force of the bed on the ball is equal to the force of the ball on the bed. Okay, so it means the force on the bed is equals to the force on the ball. Okay, this is according to Newton's third law of motion. Okay, but they are equal in opposite direction. Okay, so if this one is positive, it means this one will be negative, so that they can be equal. If I'm pushing, if this one is applying 147 towards this one will exert negative 147. So it's the same force but in opposite direction. This is according to Newton's third law of motion. Okay, I hope you still remember that law. Okay, so basically this is what you will be dealing with when you focus on this concept of impulse. Okay, so I hope everything is cleared, and see you in the next one.